Good morning. This is Apparo. I'm a chemistry faculty. I started my teaching career in 2006. So it's nearly 15, 16 years uh, teaching for the IIT aspirants and all. Now I'm teaching in some one good uh, IIT coaching institute only, which I'm not going to tell the name and all. And today, for the advanced level discussion purpose, I'm taking one topic from the ionic equilibrium, that is the salt hydrolysis. So what I'm going to discuss now is about that salt hydrolysis, the concept, a little bit of concept also we will discuss, deriving the formulas, and in which you know to remember all the formulas. So some formulas if you can derive, other formulas you can get from these formulas without remembering all the formulas. And we will be discussing some questions asked in the previous advanced exams also. By that you can understand what kind of questions that can be asked from this salt hydrolysis topic. Then let me start the topic first. In the salt hydrolysis, first we have to talk about what is this salt hydrolysis. What is the meaning of hydrolysis? Hydrolysis is the reaction of a substance with water. Reaction of a substance with water. That substance, if it is salt, we call it as salt hydrolysis reaction. Then when you put some salt in water, for example, if I take some ammonium chloride, when I keep it in water and mix it for some time, then when I put some litmus paper, you know what will happen? That litmus paper, the blue litmus paper will turn into the red color. The blue litmus paper will turn into red color. Means if the litmus paper is changing from blue to red, what kind of solution it should be then? It's an acidic solution, right? If the solution is acidic in nature, so what is actually happening inside the solution when you put this salt in water? Exactly what is happening? The salt is undergoing the hydrolysis and making the solution acidic in nature. And we have to discuss now like what is actually happening theoretically. Means when you put this salt in water, what kind of interactions that are taking place between water and this salt, that we have to discuss. Along with that, we have to discuss how to calculate the pH value of this. When suppose you are given this salt only having some so and so molarity, and when this is undergoing the reaction with water, what will be the pH of the solution? That also we can calculate. We will talk about that. So let me start with the concept of this salt hydrolysis, in which I can take the four types of salts based on the interaction of salt with water. Based on the interaction with salt with water, I can take four types of salts, in which a salt of strong acid and strong base, a salt of strong acid and weak base, a salt of strong base and weak acid, and finally a salt of weak acid and weak base. So we have four types of salts based on interaction of salt with the water. Salt of strong acid, strong base, and base is weak and acid is weak, and both are weak. So what kind of aqueous solution they are forming when you dissolve it in water? Now this is a salt. When you put it in water, and the solution will remain neutral in nature. It will remain neutral in nature because this salt will undergo no hydrolysis reaction. This salt does not undergo any hydrolysis reaction. So why this is not undergoing hydrolysis? Because this is a salt of strong acid and strong base, because both the substances are strong. And once you remember the Bronsted-Lowry theory, according to Bronsted-Lowry theory, if an acid is strong, its conjugate will be weak, right? And there, so if an acid is strong, the conjugate will be weak. If acid is weak, the conjugate will be strong. And this is the case where acid is strong and base also strong. If acid and base both are strong, the conjugate ions that are coming from this salt, this acid and base will be weak. Ante, for example, if I take the example for this salt, if I take an example for this as the sodium chloride, the sodium chloride is a salt of sodium hydroxide and HCl. Yes, HCl is a strong acid. Because HCl is a strong acid, the conjugate base Cl minus is weak. Because ammonium hydroxide is a weak base, the conjugate Na plus NaOH is a strong base, the conjugate Na plus is a weak. Here the Cl minus and Na plus, both the ions are weak only. Because they are weak, they have no tendency to react with water. Because they don't have the tendency to react with water, the salt does not undergo any hydrolysis reaction. That's the reason why the pH of the solution will remain equal to 7 at 25 degree Celsius. Because 25 degrees Celsius is the standard temperature we always used to take. In case of the salt of strong acid and weak base, in case of salt of strong acid and weak base, I'll take an example of the ammonium chloride, ammonium sulfate, ammonium nitrate, and the so many you can take organic bases. All organic bases are weak. Okay, that's why. So organic weak base you can take pyridine also. So if I take this ammonium chloride, it is a salt of ammonium hydroxide and HCl. Because it is a salt of ammonium hydroxide and HCl. So this ammonium hydroxide is a weak base and HCl is a strong acid. Because HCl is a strong acid, the Cl minus is the weak ion, right? It's a weak base, no? So it will not get hydrolyzed. But the NH4 plus, which is coming from a weak base, according to Bronsted-Lowry theory, if the base is weak, the conjugate will be strong. Because the conjugate is strong, this NH4 plus can undergo hydrolysis. Like this, NH4 plus when undergoing reaction with water, what will happen? This NH4 plus, because it is the cation, it will take the anionic part of the water. What is the anionic part of the water? OH minus. So water can be taken as H plus and OH minus. So it will take the OH minus from water and is forming ammonium hydroxide and leaving H plus into the solution. Leaving H plus into the solution. That is the reason why the aqueous solution will become acidic in nature. So the aqueous solution is acidic in nature, and very importantly, what kind of hydrolysis is taking place? Which ion is undergoing hydrolysis? Cation is undergoing the hydrolysis. We call it as the cationic hydrolysis. In case of this salt, cationic hydrolysis is taking place and solution is becoming acidic in nature. So the pH value will become less than 7 at 25 degree Celsius. With respect to 25 degrees Celsius, it will be less than 7. The same we can apply in case of the strong base and weak acid. In case of strong base and weak acid, I'll take an example over here only. That is like CH3 COO Na. I'll take sodium acetate. Sodium acetate is a salt of acetic acid and sodium hydroxide. Yes, acetic acid and sodium hydroxide. Sodium hydroxide is a strong base, so Na plus is the weak acid. So this does not undergo hydrolysis. But the acetate is actually the ion coming from acetic acid, weak acid, no? Because it is the weak acid, the acetate will undergo hydrolysis. And hydrolysis, what kind of hydrolysis? Anion is undergoing hydrolysis, so we call it as anionic hydrolysis. If anionic hydrolysis is taking place, which part of water it will take? It will take the positive part of the water because it has negative. Yes, because this is having the negative charge, it will take the positive part of water H plus and leaves OH minus into the solution. That's why solution will become alkaline in nature or basic in nature, and pH will be greater than 7 at 25°C, right? In case of this one, and in case of the salt of weak acid and weak base, what will happen? Both are the weak substances, no? Because both are weak substances, the ions coming from both will undergo hydrolysis. The ions coming from both will undergo hydrolysis. That's why both cationic as well as anionic hydrolysis taking place in case of the salt, because both the hydrolysis are taking place, and the solution may become acidic or may become basic, and it can be neutral also. It can be acidic or basic or neutral. That depends upon the dissociation constants of the weak acid and weak base. That we can discuss in detail one after the other. So this is what the theoretical part. So I'm giving conclusion of this one. So based on the interaction of salt with water, we have four types of salt: a salt of strong acid, strong base. In case of salt of strong acid, strong base, because both the ions are weak, it will not undergo any hydrolysis reaction. That's why pH will remain equal to 7. Whereas in case of salt or strong acid and weak base, because the ion coming from weak base can undergo hydrolysis, it will undergo cationic hydrolysis, makes the solution acidic. And in case of salt of strong base and weak acid, ion coming from weak acid is the anion. So that's why undergo anionic hydrolysis will make the solution alkaline or basic in nature. In case of the salt of weak acid and weak base, both the ions can undergo hydrolysis. Because both the ions can undergo hydrolysis, then the solution may become acidic or basic or neutral, depends upon the the type of like the acid and base that we are taking, and the dissociation constants of weak acid and weak base. So based on all this theory that we discussed, we have a question. Actually, we have an advanced question which is asked in 2010. In fact, based on this salt hydrolysis, some 2 to 3 types of questions can be asked. Based on this salt hydrolysis, some 2 to 3 types of questions can be asked. One is completely theoretical, and other are the calculation based. So I want to discuss all the 3 types of questions which were asked in the previous advanced exams. So let me start with that example one, which is theoretical and which is completely based on this theory that we discussed. We'll do it now. Uh, this is the question asked in 2010. In that one, of course, in the 2010 there is no advance and mains. There's the IIT exam, and that time AEEE exam used to be there, which is mains nowadays. So this is what 2010 question. Question is this: how many of the following turns litmus from blue to red? This is actually asked in the numerical value question, nothing but single integer question. So in that 2010 pattern, there used to be single integer questions. The answer for the question used to be 0, 1, 2, 3, 4, 5, 6, 7, 8 up to 9. It used to be, but nowadays the pattern is changed. You would have know that pattern. Now the pattern in which they are asking questions so that you'll get answer with 2 decimal points also. The value you'll get with the 2 decimal points also. But in the previous, like in 2010, 11, 12 and all, there used to be a single integer question. So answer used to be the perfect integer. So that is what the type in which the question is like how many of the following. This is asked in the single integer question. No, it's like this. Some compounds are given like KCN. I'm not giving all the compounds. Some I'm taking KCN, K2CO3, NH4Cl, some pyridinium salt also I'm taking. Um, ammonium carbonate, ammonium sulfate, like sodium cyanide, like some are given like this. So this is the question. Let us say how many of the following will turn a litmus paper from blue to red. For the litmus paper to turn from blue to red, what kind of solution it should be then? What kind of aqueous solution it should form? So the litmus paper is turning from blue to red. To convert into red color, the solution should be acidic in nature, right? The solution must be acidic in nature. For the solution to be acidic in nature, what kind of salt it must be? What kind of salt it must be? It should be a salt of strong acid and weak base. Yes. So asking for the substance which turns the blue litmus paper into red color. For this transformation or for this conversion, the solution should be acidic in nature. For the solution to be acidic in nature, it should be a salt of strong acid and weak base. Means what is our main requirement? What is the main motto? Motto here is that finding a salt of strong acid and weak base. Right? See, so this potassium cyanide, is this a salt of strong acid and weak base? It is a salt of strong base and weak acid, right? See, this is a salt of potassium hydroxide and HCl. HCl is a weak acid. Potassium hydroxide is a strong base. So this is a salt of strong base and weak acid. So this is not the answer. And potassium carbonate is also a salt of strong base and weak acid. Not this. Ammonium chloride is a salt of what? It is HCl, strong acid and weak base. Strong acid and weak base. And this one also pyridine and HCl. It's a salt of strong acid and weak base. And this is ammonium carbonate. Again, it is a salt of weak acid and weak base. And it is again salt of ammonium hydroxide and this sulfate, sulfuric acid. Strong acid, strong base. And sodium cyanide. It is a salt of sodium hydroxide, strong base, and HCl, weak acid. So, of all these given, how many are the salts of strong acid and weak base? Here 1, 2, and 3. So answer for this question will be 3, right? And the example, so many can be given, some more can be given. Only requirement for solving this question is you should know the salt is made up of a strong acid and weak base. Is this clear? I think it is clear. This is a theory based question. Theory based question. The same can be asked in more than option type also. Of course, this is as is asked question. Similar question if they have to ask. What kind of question they can ask? They can ask a question like the same only in more than option type. Which of the following will turn litmus paper from blue to red? They can give these 4 only. The answer will be these 2. Right? Like that, it can be given in more than option type and in single option type also, right? So we'll go to the next concept that is calculation of the pH value. So this is what we discussed related to the theory. Now to find out the pH value, how we can do that? For that, I'll be taking 2 salts, that is the salt of strong acid and weak base and a salt of strong base and weak acid. These 2 I'll be taking. I'll take the examples and let's find out the formulas also for both of them. We'll be not deriving for both. Some will derive and we'll get for the other. And then we'll do the questions also based on these 2 concepts. Then we'll see if we get the time and what else we get. So I'll take the example for this, which is ammonium chloride. This ammonium chloride, when undergoing the dissociation, it will form NH4 plus Cl minus. Because this is a salt, this can dissociate completely, right? But this cannot be hydrolyzed completely. Because it is not hydrolyzing completely, it will form ammonium hydroxide and H plus. I take the concentration of the salt as C. This will be 0 and 0. And molarity of water. Molarity of water. You would have remember this molarity of water. What is the molarity of water? Molarity of water is 55.55. You would have know this one in 2003 advanced. It was asked in 2003 IT. The question is asked like molarity of water when the density is 10 power 3 kg per meter cube. Density is given in kg per meter cube. Asked for the molarity of water, that is 55.55 and all. Because that is of very high concentration, I am taking it as constant and ignoring it. And I take H as the degree of hydrolysis. Degree of hydrolysis is the H in 1 mole per liter. If I take 2 mole per liter, that will be 2H, right? If I take C mole per liter, that will be CH. Then how much will be left then? C minus CH, and this will be CH and CH, and for this water I have ignored. Then I take this KH expression for this. What is the KH? Because it is the hydrolysis reaction, the equilibrium constant is KH, which is equal to this CH, this into this by this one, right? Okay. If I take that expression also, the concentration of ammonium hydroxide into the concentration of H plus by the concentration of NH4 plus. I have ignored water. In fact, I can take water here, taking water here and sending it to this side and making the total as a constant. Instead of that, I have ignored before itself only, right? Now I'll be substituting CH, this is CH by C minus CH. H I can cancel and I'll get the KH is equal to CH square by 1 minus H. And very importantly, if the H value, this is the assumption given by IUPAC people only. We are not taking any assumption, understand? We are not taking any assumption. This is given by that the IUPAC people only, in which if H value is less than 5%, if the H value is less than 5%, then we can take 1 minus H is equal to 1. Then what will come? KH will come equal to CH square. It is CH square, and the H value is equal to square root of KH by C. H value is equal to KH by, so here, so H equal to square root of KH by C. And if I take that the H plus concentration, I'll be taking some space from here. So H plus concentration is equal to square CH, no? CH, and CH value if I substitute square root of KH by C, this will come equal to square root of KH into C. Okay. And one more thing I have to add here for the KH. KH is equal to KW by the dissociation constant of the weak substance. What is the weak substance here? Base is the weak, no? So that constant will come Kb. I think you can guess what will come in case of this. What is the weak substance here? Acid is weak, no? So KH for this salt will be equal to Kw by Ka will come. If acid is weak, Ka will come. If base is weak, Kb will come. If I substitute in this one, and if I get for H plus is equal to the square root of Kw by Kb into C. And if you apply this pH value for this one, pH will come equal to half of, so this Kw, pKw plus pKb plus log C. Okay. At a 25 degrees Celsius, if I take at a 25 degrees Celsius, what will happen? This will be this can be replaced by the 14 now. If I replace by 14, the pH will come is equal to 7 plus half pKb plus half log C. This is what we'll get for the pH. You can remember the expression also. 7 plus will come. Will it come plus? No, this will come equal to pKb minus will come now. So half of pKb minus half log C. And here also 7 minus this one and 7 minus half log C. In fact, 7 minus everything will come. In case of this one, pH will come equal to 7 minus everything. Because this is salt of strong acid and weak base, solution acidic in nature, pH will be less than 7, 7 minus everything. Now this is what the pH calculation. In one case, in one place, you should be very much careful. At one place, you must be very much careful, somewhere where it is here. If the H value is less than 5% only, you can make this assumption. Then you can take this, then you can substitute in this, and you'll get all this. If the H value is not 5%, less than 5%, if it is greater than 5%, this is very important. If it is greater than 5%, you must be careful with this calculation. We will do a question also. There is a question in 2008. One question has come in the IIT exam. So where if you are not careful about this 1 minus H assumption, then you will get one wrong option. Options are given like that. Options are given to force you to make mistakes. That's why. So that also we will discuss. This is what for the salt of strong acid and weak base. In case of salt of strong base and weak acid, in case of, I'm not giving all these examples, I'll be directly giving the formula. This I'll take directly for this. You can remember it. What you can take for H? KH is equal to CH square by 1 minus H. And if there is the assumption, as is assumption, we can apply. If it is the less than 5%, you can take it as 1. Then KH will come equal to CH square. Then KH will be not KH, then H will be equal to square root of KH by C. Same as this. Then what will come here? Because it is a salt of strong acid weak base acidic solution, expression is given for H plus. Now because this is for the basic solution, the expression will go to OH minus. If you derive, it will come, but you don't try to derive everything. Just derive one and get the other one so that you can remember formulas easily. If you start deriving everything, it will become more complicated. Okay? So OH minus is equal to square root of same as this one KH into C for OH minus. Then so what will come for KH then? KW by, what is the weak substance here? Acid is weak, no? So Ka will come. So KW by Ka will be the expression for KH. And if I substitute everything in this one, so you get for OH minus, and if you apply, the POH formula will come. POH is equal to 7 minus half pK. What will come? A or B? A kada? So A minus half log C. Compare the formulas. In both the cases, you'll having similar formulas because it is for acidic solution for H plus, basic solution OH minus. Whatever formulas we have for H plus here, same formulas we are getting for OH minus here. And if you extend this little bit, if you want to get for the pH only, here also if you want to get for pH, what we can write? pH equal to 14 minus pOH kada? 14 minus pOH, 14 minus of this will become 7 plus half pKa plus half log C. This is what the expression you can take for pH in case of basic salt. pH is greater than 7, no? Because pH is greater than 7, 7 plus everything. Because pH is less than 7, 7 minus everything. Is this clear? Okay then. So then what we'll be doing is, we'll be doing those two questions. The two questions which were asked in the exams. One question is 2009 question. I'll be taking 2009 question. This asked in IITG in 2009. This is actually a direct question only. This is a direct question asked in advance and numerical value question only. But it is not a very difficult question as per me. The question is this. I'll be giving the question. Then we'll discuss the method also. So the dissociation constant of a substituted benzoic acid is 1 into 10 power minus 4 at 25 degrees Celsius. The pH of 0.01 molar sodium salt of it is. This is the question. So dissociation constant of the benzoic acid, but substituted benzoic acid is given, and the pH value is asked for its sodium salt. Benzoic acid is a weak acid. Yes, benzoic acid is a weak acid. Asking for sodium salt of it. Sodium hydroxide is a strong base. So the salt of sodium salt of weak acid will be what kind of salt it is? Sodium salt of it will be a salt of strong base and weak acid. So what kind of solution it is? Alkaline in nature. If it is alkaline in nature, how we can get the pH value? If you remember that pH formula, I'll be explaining two ways. I'm explaining this question in two ways. One, calculating the pH value directly, and other one is um, calculating OH minus, and from that calculating pH. Both are same only. Anyway, you can solve the question. That's your interest. pH is equal to 7 plus half pKa plus half log C, right? So this is equal to 7 plus half. What is the pKa value? pKa value, this is the Ka value, no? If Ka is 10 power minus 4 and pKa will be 10 power 4 or 4, it is only 4. So this is 4 plus half of log, what is the concentration given? 0.01, so means 10 power minus 2, and this is equal to 7 plus 2 plus this is minus of log of 10 power minus 2 will be minus 2 by 2, it is 1, minus 1, 7 plus 2 9, minus 1 it is 8, pH is equal to 8. This is a directly formula based question only, formula substituted question only. There is nothing tricky in this question. If you want to solve the same question in another way, how? You can calculate the OH minus square root of KH into C. How you get KH? KH is equal to KW by KA. Yes, what is the KW? 10 power minus 14 by what is Ka? 10 power minus 4 given in the question. So this is 10 power minus 10, that will substitute in this. So square root of 10 power minus 10 into what is the C? 10 power minus 2 kada? 10 power minus 2. This is 10 power minus 12 under root of this 10 power minus 6. So OH minus is 10 power minus 6. Then what is POH? Is equal to 6. Yes or no? POH is 6. Then what is the pH value? pH is equal to 14 minus 6, which is equal to 8. Either you do by directly substituting in this pH formula or calculating from this OH minus, you will get the same. Which method you are using depends upon your personal interest and which you will remember more effectively. I am not telling you to remember both the formulas. Remember any one formula and get the answer from that. It's not compulsory to remember this formula or that formula like that. So this is what the question, but this is a directly formula based question only. Asked in the single integer question in 2009 for plus 4 and 0, because marking scheme used to be plus 4 and 0. Another one question we'll be discussing now. This is a very nice one. This is a very nice one. The question is this is asked in 2008. In 2008 IITG, this was asked. The question is, when 2.5 ml 2 by 5 molar mono acidic base, its constant is given Kb equal to 10 power minus 12. is titrated with 2 by 15 molar HCl. Find the concentration of H plus at equivalent point at 25 degrees Celsius. This is a very nice question. I'll give the options also for this. It looks more nice with the options. This is some 3.7 to 10 power minus 13 molar, 3.2 into 10 power minus 3 molar, 3.2 into 10 power minus 2 molar, and 2.7 into 10 power minus 2 molar. Let me explain this reaction. So first we have to discuss about the equivalent point. What is this equivalent point? The point at which acid is completely reacted with the base. Now I will take this base as BOH. When this is reacted with acid like HCl, it is forming BCl and H2O. Let's find the number of millimoles of this base. What is the number of millimoles? So molarity into volume kada 2 by 5 is the molarity into volume 2.5. And HCl, how much is this? It is 2 by 15 into volume is not given. Let's call this as V. The volume of HCl that is reacted also is to be calculated. That's also very important. So let's call this as a V. So what is this equivalent point? The point at which number of equivalents of acid and base both are equal. Because both are equal, I will equate these two. I'll equate these two. I'll get this V. This is 5 by 5 will be 1. So V is equal to 15 by 2, 7.5 ml. So volume of HCl required to react with this base is 7.5 ml. Now I'll get the concentration of BCl salt, because at equivalent point what we are having only salt. So that's why we have to get the H plus by taking salt hydrolysis concept. Correct? So salt of this is moles by volume. What is the number of moles of this? What it is? Salt. 1 mole reacts with 1 mole, produces 1 mole. This is 1 equivalent to 1 millimole. 1 millimole reacting with 1 millimole, producing 1 millimole. By what is the volume? This is 2.5 ml. This is 7.5 ml. Both together 10 ml. So 0.1 molar. Okay, 0.1 molar. How will get H plus for this salt? What kind of salt is this? It is a salt of strong acid and weak base. So we'll get by CH. What is this C? 0.1. And what is this H value? To calculate that H value, we have to take the concept. If we take H value equal to square root of KH by C. What is this KH value? KH value equal to KW by KB, because the base is weak, no? KB into C if you take, this is 10 power minus 14 by 10 power minus 12 into 0.1 if you take under root of this. This is 10 power minus 13. So 10 power minus 1 square root of 10 power minus 1 will be 0.3162. H value is coming equal to 0.3162, nothing but 31.62%. 31.62% we are getting H value. That if you take here 0.3162, what will be the number that is coming? 3.16, about 3.2 we can take into 10 power minus 2 molar, which is the option C, which is not the answer. That is wrong. Answer C is not the answer. This option C is not the answer, because the H value that we are getting is 31.62%, greater than 5%. If it is greater than 5%, taking this formula is wrong, right? This we cannot take, no? I have already told you in that hydrolysis, you should be careful. Always have to check whether the H value is greater than 5% or less than 5%. Because here it is coming greater than 5%, this will be wrong. Then you have to do exactly how you have to do. You have to take the KH is equal to CH square by 1 minus H. What is the KH value? This one, 10 power minus 14 by 10 power minus 12, and C nth 0.1, and H square by 1 minus H. And this is what a quadratic equation. After solving this, the H value will come equal to 0.27. Then this is the correct H value, not this, because this is with approximation. This is after substituting the exact values. That if I substitute here, it will come 0.27. So 2.7 into 10 power minus 2 molar. That will be the option D. Absolutely correct. So if you make this mistake, you will get the option C, which is wrong. You have to get the correct one, option D. That's why you should be careful while solving the questions. And these are all the questions based on the concepts. And in the time that I got, I could explain this. So if I get more time, I would have explained the salt hydrolysis of the salt, like the FeCl2, ZnCl2, even K3PO4, potassium phosphate and all also. But I'll conclude at this moment. Thank you for this opportunity. Thank you so much.